Hello, class. Today we're going to look at a new concept called compound interest. And I'm sure you've heard about compound interest. So, if you think about how banks operate, you give them money, you take your money to them, they invest at a certain interest rate, and over a time period, you accrue some you accrue some interest, and that's added to the money that you brought to the bank. So, the question is, how is this tied in with exponential functions? So let's do a little proof and let's see. So the amount that you deposit at the bank, we're gonna call the initial amount, which is called the principal, which is represented by the letter P. The bank is gonna tell you that they're gonna invest your money at a certain interest rate, which is normally in percentage. We're gonna call that R for now. And then there's a time period for this investment, which we're going to call T. So when we say interest, the interest comes about by multiplying P times R times T. So for this example that we're going to use, let's say that our time period is 1 year. So we take the money to the bank and we tell the bank, I'm not going to touch this money for the next 1 year. Do whatever you want to do with it. And at the end of the year, just tell me how much money has been added to the initial amount that you put in. Okay, so let's look at year one. So year one, after investing your money, it's gonna be P. That's your principal plus the interest that has accrued. The interest is gonna be P times R. So at the end of the year, we can say that this is P plus PR, which is the same as P1 plus R. Now, this becomes the new principal for the next year. So year two, you're going to invest again. You don't touch your money. So at the end of the year, they're going to tell you that you started over the year with P times 1 plus R plus now P 1 plus R times the interest rate. So you end up with P 1 plus R, and then I have 1 plus R, which is equal to P 1 plus R squared. In year three, you start off with your initial. So this is also the new principal, right? Plus the interest that has accrued. Remember, interest is always P times R. So your new principal, which is P1 plus R squared times R. Now, that amount, let's call that A. Let's call this A. And let's call this guy here A2, so that we are being consistent. So I end up with P1 plus R squared times 1 plus R. That gives me P1 plus R cubed. So I think we've made a case now. So let's see what's going on. If I look at year one, I end up with this expression, P times 1 plus R. In year two, I got P times 1 plus R squared. In year three, I'm getting P times 1 plus R cubed. Well, if you look at the expressions very carefully, it looks exponential. 1 plus R seems to be the base. And 1, 2, 3, if I call that raised to the T, is the exponent. And then you have a P multiplying it. If you think about transformations, P is stretching it. Also, P is pretty much making it's like a stretching factor. Pretty much that's what it is. So you can clearly see that this is an exponential function. It's got a base and it's got a what? It's got a power. Okay. So the question is, what happens after t years? So for t years, we're going to end up with the amount, which we're calling the amount is what we are calling the compound interest, is going to be P 1 plus R raised to the T. All right. But the banks don't operate on a yearly basis. So they can have different portfolios that you can kind of work under. So one thing we can look at is if your interest is going to be compounded, so the interest is R and you're going to compound at N times per year, then this formula here is going to change slightly. So let's think about it. Say that you wanted to invest your money semi-annually. So that means after every 6 months, you want them to invest your money. Then every year, you're going to do this compound interest twice. Well, that means that they got to take that interest rate that has been given you for the year and divide it into 2. And then do this twice in a year. If you wanted to invest your money in a quarterly fashion, then 12 months divided by 4 is every 3 months. So every 3 months, they're going to try and invest. No, sorry, I take that back. That's right. Every quarter means every 3 months. So 4 times in the year, they're going to invest your money. So if you think about what's going to happen to the interest, you have to divide the interest by 4 so that they can invest that. And that's going to happen 4 times in a year. All right. So if you think about how this is happening in an expression, then we're saying that the amount is going to be P1. And no matter how many times I want to divide the year into with my interest rate, that's going to be 1 plus what? R divided by N. And because I'm dividing it into N times, I need to show that they're going to compound that many times. So that's going to be N times T. All right. So let's look at the example they have over here. So if you look at what the textbook is saying, it says that if the annual interest rate is R and if the interest is compounded in times, then for each period, the interest rate is going to be R over N. And then that is done what? N times T time period for T years. So let's look at the example that they have over here. So the definition that I just noted over here is right here with the meaning of what each of the letters mean. So A is the amount of the T as a compound interest after T years. The P is the principal. The R is the interest rate per year. N is the number of times interest is compounded per year, and T is the number of years. So let's look at this question over here. You have $1,000 and you want to invest it at these different compounding times. So if you think about it annually, you have $1,000, that's your principal. And then since you're doing it annually, you have it divided by 1, and you're doing this for 3 years. So it's 1 times 3 years. If you divide this, if you want to compound it semi-annually, so every 6 months you want to do this, so you're dividing your interest rate by 2, but then you're doing this for 3 years, so that means that you'll be compounding at that semi-annually rate 6 times, so the power becomes 2 times 3, which is 6. If you're going to do it quarterly, you're dividing by 4. So it becomes R divided by 4. And since it's quarterly, you're doing it for 3 years, that means you're going to be compounding quarterly 12 times at the end of the 3 years. Note that the interest rate is represented in a decimal, as a decimal number. So the interest rate will be given to you in percentage per year, but you need to convert that into a decimal representation. Okay. And likewise, you do monthly, you got 12, and it's 12, so you divide the rate by 12. So if you're going to do this for 3 years, you're going to be compounding monthly for 36 times in a year. 36 times during that time period. And then daily is every day you want to compound. So that means that for 3 years, that's 365 times 3 times that you will be doing this. And you divide the rate by what? 365. Okay. Now, let's look at something that is derived from interest rate. So we define what we call an annual percentage yield as the simple interest that yields the same amount at the end of 1 year. So let's see how this works. All right. So all it's saying is that after 1 year, under any of the compounding periods, what is the interest, the actual interest that you're really being invested under? Okay, so if you look at the question that they have over here, it says, what is the annual percentage yield for investing for an investment that earns interest at a rate of 6% per year, compounded daily? So remember that this is 1 year times 1 year. All right. So for 1 year that you're compounding daily, this is what it comes out to be. This is the expression that you end up getting. If you do 1 plus 0.06 divided by 365 raised to 365 times 1, you end up with this nice expression over here. All right. Now we're going to take this and we're going to compare it with what it means if this was done on a yearly fashion. All right. So say that this was compounded yearly. Then what it's saying is you can compare the number that is inside with this number here. So you have 1.06183 is equal to 1 plus what? 1 plus R. So what is R? R is going to be 0.0618, which is equal to 6.18%. So if you compounded daily, really your interest wasn't 6%. It was what? It was 6.18%. All right. In comparison with you doing it on an annual basis, this is what the interest rate that was really working for you for that investment. Okay. That is it. Okay. Hopefully this is helpful and you should be able to do some of your homework. All right.